things here written. We are working with file system. Now, there is another user. Okay. This user wants to access this file. Okay. So there is a mechanism. This owner can give a read access or write access to this file, F1, to user 1. This is possible. But the problem with this one is that we can do it very simply in Linux. You know, there is a access bit. You can set the access bit, and automatically that user will get the particular access pattern. What you want to offer him, maybe read or write or what. But the problem with this one, if you give access to read this file to this user, he is allowed to view everything, every item. It is not possible that, okay, I will hide this two thing from him. It is self-contradictory in a file processing system because the file itself is a single entity and it is working just like a single entity. So if you give access to the file to a particular user, he will have direct access to entire content of the file. But this is not what we want. In your database, we have a lot of sensitive information for a particular item, person, that cannot be shared or cannot be updated by user itself, like salary, for example. So this is an important issue that security, ensuring security in file processing is a challenging task comparing with the database, because a database has a different way of maintaining these security issues. Is it okay?
Yes, sir.
Now, we have three layers of abstraction. One is physical level, okay, and logical level and view level. In simple words, what is physical level, what it does is normally it's very low level abstraction. That means how really data are actually stored in your hard drive, in your secondary storage. Okay, so it deals with complex low-level data structure in detail, but in database area, these are not handled by the programmer or the designer. So we are not going to cover this one. Okay, these are the things normally dealt by manufacturer of the database particular. Okay, then we have on the top of this, we have another layer, that's the logical level. What is logical level is the description of data. What are the data we want to store, how they are connected. Basically, we need what data to store and what is the relationship among these data centers, data parts. This is the core part, and this is the design part. If you think, this is the original design that you will learn. Design of a system. When you think of a design of a database system, we actually point to the logical level designing. Okay. And finally, on the top of this, there's a view level, how you want to present your data to different users. Okay. Is it clear?
Yes, sir. It's clear.
Then we have database architecture. In old days, there were two-tier architecture. You see, there is two-tier architecture. This is early generation. The structure is very simple. Okay, we have just one machine as a server, and there is another machine as a client. And on the machine, the application itself is hosted. Okay, so let me draw it. It should look, it's a two-tier. Okay, two-tier will look like there's a server. Okay, DB server. Okay, now you have a lot of clients. Okay, This is a client 1. This is client 1, client 2, this is client 3, client 4. All are running the same piece of software. So what will happen? You have a copy of the same application here. Okay. You have a copy of the same application here, and you also run the same application here and same application here. This is called two-tier because we have only two tier. One is client, another one is server. It is also called client server. Okay. Is it clear?
Yes, sir.
Yes, sir.
Okay. Now, the advantage, because I told you this was the old structure. Even when we used to write programs, commercial applications, I have some experience of configuring this sort of architecture. In old days, back in 2006, 7, we had to configure our system in this way. Okay. Now, the positive side of this architecture is the strength is it is just directly talking to the server. You see, all communications is directly to the server. So it is very fast. Okay. But the main problem, negative side of this architecture is that suppose I need to update the piece of software that I'm running with minor updates. So what you need to do, you have the source code, you have to update the source code, you have to make the binary, and then you have to reinstall in everywhere all the plans. Okay. So the main problem of this architecture, why it is obsolete now, the main problem is that it is very difficult to update, especially update software version. Okay? If you want to update the software or application, then it is really difficult. It takes a lot of effort. Because you can think of a large company where there are 300, 400 clients connected to a single server. And if you have a minor update event, so you have to go to the 400 PC, reinstall it, see whether the connection is okay or not. So it is very tiring work. Is it clear why two-tier is no longer used?
Yes, sir.
Okay. Now, what is the solution then? Solution is very simple. We call three-tier. Three-tier architecture is very simple. How it works? We have a database server. Okay. We have clients. We have a lot of clients. These are the clients. And now they don't communicate directly to the database server. In between these two tags, there is another guy we have added. We called app server. Okay. There is the application server. This application server can directly communicate to the database server one-to-one. There's no problem. Normally, they are two separate machines. Okay. In physical world, in a real implementation, this is one machine, this is another machine. Okay. But for a small system, you can use one system, one machine as well. But in a real deployment with large number of users, we have two separate machines. Now, what will happen? The clients will be connecting to the application server only. Okay. So it will communicate to this application server through some API. Okay. Okay. Yes, you can claim that. Yes, response times could be affected, but there are standard techniques, state-of-the-art techniques, how to make it faster. So that is no longer a big issue, the response time. Now, what was suffering for the two-tier was that update of the application. Now here you see, if you update, you update only this code and you don't need to do anything with the clients. You update only the application server and update is automatically propagated to the respective clients. This is the strength of three-tier application, and modern world is actually working on this three-tier application because it is very easy to maintain. Everybody clear about this one?
Yes, sir.
Then we have some history. It's not that important, but you should know as it is in the book. I have to discuss few things. Just you should know as an interesting event. Okay. You see, the journey started long ago. The journey started 1950s. So I told you that it is more than 50 years old technology. So it is a very mature technology. Okay. So people used the punch card and other things at that time. Then the basic data model of relational data model that was actually coined by a very famous computer scientist. His name is Codd, Ted Codd. He is very famous in the area of data science. Ted Codd, he was the first to propose this concept of relational data model. And for his revolutionary work, he was awarded with the highest award of computing. Do you know what is the highest award of computing or computer science? It is called Turing Award. Okay. The SCM Turing Award, sometimes people call it, this is the Nobel of Computer Science and Engineering. So for his excellent work in this area, he was awarded the SCM Turing Award. And then two companies actually started the work. One is IBM with the R prototype, and then Oracle database. They released their first database at that time. Okay. After that, in 80s, we have some updates. The important update is that they standardized the SQL, structured query language. They have it becomes an industry standard. Why you need the industry standard? Because you develop one application in MS SQL Server, another one is Oracle. Now, if you want to transfer one application from here to here, which is written in SQL, then you have to rewrite everything in its Oracle platform if you don't have any industrial standard. But if you have the industrial standard, just like we have for SQL, then transforming this application to Oracle is very simple and very fast process because they are almost identical because they follow a set of standards. Is it clear why we need the standard, industry standard for SQL?
Yes, sir.
Okay. Then we have few features like distributed and parallel database, object-oriented systems. Although it was not that popular, but there was time when people tried to invent, think everything like object-oriented programming. Table is a object, so it has constructor, destructor. You can overlap the function, overload the function. These concepts are already there, and still it's there. Although that was not very popular. Then in 90s, we have the concept of data warehousing and mining. Okay, these concepts are actually for decision making. Okay, we want to see the trend of something, then you have to go for a different modeling techniques. That's for data warehouse modeling, and the algorithms are dealt with a different branch of database. That's called data mining. Data mining is knowledge mining. We have data now, from what knowledge I can infer from this data, that is called data mining. Then we have the web applications. Now we all know it. Then the journey goes on. There's a milestone in this 20s. Very, very big changes are there in the history. So the changes, major changes is from relational to non-relational. So people start thinking in a different way, completely different ideology, that what if we can make a database that does not depend on different relations. Okay, so as a result of that, we have a system called NoSQL system. I think you know this term, NoSQL. Hello.
Oh, sir.
So I think you know it, the NoSQL.
Yes, sir.
Okay, so we'll try to give you some idea at the end of the course as a trending applications. NoSQL is very trending, but remember it is not suitable for all sorts of applications. Okay, it is suitable only for specific applications where the scale is very important. Other things you can ignore. The accuracy, security, those are okay, but the scale is very important. For example, online food delivery. Think of the nature of this application, online Pathao or Foodpanda. Security, okay, performance, integrity, who cares if you have sale? There are thousands of users requesting at the same time, lot of conflicts are there. So how you can resolve it? That's the use of NoSQL, not always. Okay, so don't be confused about NoSQL comes, so we cannot use the relational database. That's not true at all. Then we have big data analysis. This is also a very trendy term, big data analysis. You need to know why this is important, because again, there are some applications where the traditional relational database is unable to answer. Simply it cannot, because the number is so big. If you cross compare one by one, then it will take several days to give a simple answer. So they have a different architecture, and that falls into the category of big data analytics. Okay. One example is Google search. Google search is a big data analytics result. Google search does not use the relational database. And then we have the scalability issues of availability for NoSQL, the commercial application of NoSQL. Now we have NoSQL. For example, MongoDB is a NoSQL database, and Neo4j is a graph database. All these are some of the examples of NoSQL database. And we have the cloud service that makes life simple for maintenance. Now you can buy something on the online with few dollars and with the excellent service of online, and even you can buy the database as well with very nominal costs if it's the open source database or something like that. Now, there are two types of database. You should know it based on licensing. Okay? Based on licensing. One is proprietary, and of them, the most important database in the world is Oracle Enterprise Edition database. Okay, they are the leader in this market, no doubt, because they have been working from the very beginning. They have a very, very strong experience, okay? And their customer base is very strong. So, for example, in Bangladesh, who are their customer? Do you know?
The banks.
All banks, no doubt about all banks. It's undoubted all banks. And who else? Bangladesh government. Okay. For its NID. Okay. So you can understand that their scale is important and the cost is too high because you cannot afford it. It's enormously expensive. Okay. It's only possible by the banks and the country and big agencies. Okay. So their target is like that. And then we have a Microsoft solution, SQL Server, that is moderately good database. And we have DB2 of IBM. Okay. These are proprietary product, meaning you have to buy it for a specific time, okay? And you have to again buy it. You cannot use it free. Now, apart from that, we have another sort of database that's like any other software, it's open source. Free and open source, we call it FOSS. Of them, the most popular is, I am sure you all know, MySQL. And recently, we have MongoDB, although there's a difference, that is a NoSQL database. And the relational is PostgreSQL. So out of these three, these two are in the same group. Okay, this is a bit different NoSQL, but all three are open source database. That means you can readily use it without any licensing or spending anything on it. Okay. Hello.
Yes, sir. Understood.
Okay. So this was the pending part of the chapter 1. Now I have another chapter, but I don't know how long we can go because we have very few minutes only here. Let me check it. At least I can start few things. Okay. Can you see it?
Yes, sir.
This is the chapter 2. Let's begin at least. We have so far in chapter 1, we have given you very introductory ideas about the relational database. What is a relational database? What is its history and how it evolved? And what are the target applications around you? Those were the conceptual elementary ideas of a relational database. Actually, the real understanding of database will start from this chapter, chapter 2. Okay, we'll start directly with the basic concepts of database. So we have a number of topics here. The structure of database. Then we'll discuss database schema and key. That's very important. I think today I'll not be able to touch it, but that's very important. Okay. And then we have few other things like the notations, relational algebra. These are just symbolic things, but those were used to invent the SQL. Okay, so they have some theoretical background, and those theoretical validity can be only checked using the relational algebra. So that is also very important for basic understanding. Now, the motivation, although I have told you a lot of things like NoSQL, okay, big data or whatever, be sure of it that even today in 2025, majority of the commercial data processing application, listen carefully, majority of the commercially data processing applications fall under the hood of relational model, the traditional relational database. Still, it is the primary data model. Okay, is it clear?
Yes, sir.
Why? Because it has a power of simplicity for designing. You will see when we will learn the designing stuff, how to design a system, and it is really very flexible. And actually, whatever you can imagine, you can implement here using your design simplicity because it is very simple and very powerful in its own way. So the simplicity is the power of this relational database. Just we have two things. We have two connectors. We have a primary key and we have a foreign key. That's it. Using these two tools, we can design any complex system. Okay. So the simplicity is the main strength of a relational data model. And new features have been added like object modeling. Previously, we have only scalar data. Now we have complex data. Okay. Like the image, video, and all these things. And we can also write programs like C as a function. For example, what is a function? Function is a stored program that takes some inputs and returns some value. So the same concept is valid here. You can write some program. Maybe let's give an example that I can write a program in SQL in a way that That will take my ID as a parameter. It will find out how many courses I have taken, and it will return the number of courses. You understand it?
Yes, sir.
Okay, so that is called stored procedure. That is called stored procedure. You will learn very basics after the midterm of stored procedure in advanced skill. The model is well matured. I told you before that it has a experience actually more than half a century. So the performance, the securities, those issues are well tackled. Concurrency. Now, a few things here. We have table. Table, what is a table? Relational database consists of a collection of interrelated tables. Okay? The table means it is a structure. Okay? You can think this table is nothing but the structure of your data. What are the things you want to find out? Okay? So how a table is defined? Table is defined in terms of its attribute. Okay? Attribute. Attribute is the way we define a table. For example, this is a table instructor. How it is defined? It is defined by attributes ID, name, department name, and salary. Okay. And we have another thing. This is called a record. Okay, this is a record. Okay, that means it is record or row or tuple. It's all same. Okay. Is it clear about this three terminology?
Yes,
One
sir.
is
Yes, sir.
One is table, the basic structure, how you want to organize, and then individual element of that organization. Those are called attribute or field, okay, or column or whatever. And then the real data, when you feed it, you feed up with the data. Those one set of data is called a record. Is it clear?
Yes, sir.
Okay. I think I have to finish now because we have the prayer as well. How many of you are present? Everybody present? Are you present all? How many are present? Let me check it.
Sir, I think 50 people.
Okay.
Most of us are here.
Then okay, then almost all are present. Okay. Okay. So thank you very much. We will see you next, inshallah, in the physical classroom. Assalamu alaikum.
Assalamu alaikum.
Assalamu alaikum, sir.
Walaikum assalam, sir.